to name disubstituted compounds of benzene. A disubstituted compound of benzene is a compound of benzene that has the two hydrogen atoms substituted. In other words, the compound will now have C6 and the H4 alongside with two other atoms that have taken the position of the other two hydrogens. So let's see the pattern of naming them. Okay, this will serve as a model. We considered here as number 1. So we use this as a reference position to relate other colors. Now, from this position to this position, which is called 1, 2, if you count, this is carbon 1, this is carbon 2, we use the word auto. There are 3 things we use to describe positions of the disubstituted compounds: auto, meta, para. Auto, meta, para meaning 1, 2, 1, 2, 1, 3, 1, 4. Auto means 1, 2. Then, if you start from here, carbon number 1, you count 1, 2, 3, getting to green. Black to green is meta, meaning 1, 2, 3, that's 1, 3. But this black to blue should be 1, 2. Then black to black should be 1, 2, 3, 4. This should be 1, 4. The same thing is applicable here. 1, 2. This is auto. Then this is also meta. Then this is also para. So let's see the real numbering. But listen up. If you consider this blue and green, if you take this place as number 1, it becomes 1, 2, 3, 4. This becomes para still. But if you consider this blue and this adjacent green, it becomes also auto. This blue and black, this one should also be meta because it should be 1, 2, 3. So 1, 3 means meta, then 1, 4 means para, and then 1, 2 means auto positions. And the compounds are also called that name: ortho-compounds, meta compounds, and para compounds of benzene. Okay, let's see the sample here. This is just what I explained. Taking this black to black is para, that's 1, 4. Then black to blue, 1, 2, auto. Then black to this is meta, just the summary of what I've explained. And then watch this: 1, 2, and 1, 6 are equivalent. So you don't use 1, 6, you use 1, 2. Then 1, 3 will be mistakenly counted as 1, 5. Don't use it. You use a 1, 3, which is called meta, as clearly explained on the screen. So let's see the separated explanation for each of these positions. We'll start first with auto. Okay, this is the auto position. Like I rightly said, this will tell you the correct and the wrong numbering. If you number like this on the inside, 1, 2, 3, 4, 5, and 6, you get now 6. This is wrong. It should be this way: 1, 2. So 1, 2, die A. That should be the correct thing. So when they are not separated at all, when they are adjacent, you use the word auto. The same thing here. So nobody tells you to number clockwise or anti-clockwise. There is nothing like that. It depends on the position of the substance group. So let us see meta. You see, our class has gone digital. We have many things to make learning easier for you. With this, we can even teach you everything possible. We can do all these things. So you are advised to subscribe, okay? And tell your friends about this. This is meta positions. You have seen this. When it's separated by 1 carbon on one side, you just use meta. Whether it is the other way, 1, 2, 3, 1, 3, that is meta. Here, don't count 1, 2, 3, 4, 5. Rather, take 1, 2, 3, because 1, 3 is lower than 1, 5. This is meta. So all these examples here are meta. If the substance group are here, meta. So if this A now is chlorine, we can now say that the name of this is M-dichlorobenzene. The M means meta, telling us that the 2 chlorine molecules are situated at carbon number 1 and number 3. So all these things here should be meta positions. So let us see para position. Okay, this is para position. Whenever they are straight, when diagonals are connected, that's para position. 1, 4. 1, 2, 3, 4. Unlike auto and meta, any angle you count from, you must get 1, 4. 1, 2, 3, 4. This is para position. 1, 2, 3, 4. Para position. 1, 2, 3, 4. That's para. So if a substance group here, if bromine is here, you should just say that the name of this compound becomes P-dibromobenzene. In other words, the correct alphabet name should be 1,4-dibromobenzene. So to cut it short, you can just replace that 1, 4 by using P. So these are para compounds. Let's take a look at some examples of what we have just said now and how we can name it. Okay, this is it. So these ones here are showing the possible position. the chlorine here, the two atoms are adjacent. Therefore, the name is 1,2-dichlorobenzene, which means that the name from what I taught you should be what? It should be O2. O-dichlorobenzene. You replace this 1,2 with O because 1,2 means O. Here you replace the 1,3 with M because 1,3 means metal. So this is M-dichlorobenzene, while this is now P-dichlorobenzene because 1,4 represents para. Okay, that's it. See their positions 1, 2, 3, and 4. This para compound, this metal compound, and this ortho compound. So let's see the next example. Okay, this also. Now it should interest you that C6H6 is benzene, but C6H5 is what we call phenyl. But C6H4, which is remaining, that's assumed we neglect this ammonia amino group. What remains is H4, 1, 2, 3, 4, and carbon still remains 6. So C6H4 is called phenylene. So this one should be in which position? Can you guess? Yes, this should be in O position, meaning 1, 2. So this can be called O-phenylene diamine. O-phenylene diamine. The phenylene means the C6H4. That's this one's remaining is phenylene. The diamine, because there are two amino groups. Then this one should be M-phenylene diamine. Then this should be P-phenylene diamine. So that's the way to name the disubstituted compounds of benzene. Let's see other examples. Okay. So you see this. This is actually phenol with other. Okay, this is not phenol. Phenol is only when we have one OH. This is in P position. This is in O position. Then this is in M position. So if you are asked to name this, you can call this benzene 1,4-diol. Benzene 1,4-diol, which is the same thing as saying p-hydroxybenzene. This is p-hydroxybenzene because there are two OH attached to it. P-hydroxy or say p-dihydroxybenzene. This is commonly used in your body cream for skin lightening, though it's not other friendly. It goes against melanin production. That's what they call I've forgotten the common name, but it's commonly used in your this body cream for bleaching of the skin, though it's dangerous. You see the name on the screen. Okay, this one is O-dihydroxybenzene, while this one is M-dihydroxybenzene, P-dihydroxybenzene, O-dihydroxybenzene, and M-dihydroxybenzene. Okay, so these examples, these are the ones we call xylenes, common names. So from what we just talked about, this methyl, this methyl. Remember, when there is only one methyl group, we call it toluene. But here we have two methyl groups. The two methyls are in 1,2 position, so we call it 1,2-dimethylbenzene. Then dimethylbenzenes are commonly called xylenes. But the CH3, CH3 are in 1,2 position, therefore this is called O-xylene. This one can now be called M-xylene, and this is called P-xylene. P in the sense of 1, 4. Then this one is just ethylbenzene. It's just showing part of the isomer. It's not showing the para, meta, or ortho position. It's just to remind you that there are 4 isomers of xylene. Means methylphenol. Methylphenol is called chrysols. So this one is also 1, 2. Then this is also 1, 3. So this is 3-methylphenol. So which means, take note, it is not the CH3 that guides the counting, it's the OH that guides. So normal numbering should be 1, 2, 3, 4, not 1, 2. Though if you start from any side, you get the correct thing. But the normal functional group is the OH, and that's why it has phenol. So methyl here is having as a substituent group. So here the OH is number 1. The next substituent group is in the carbon number 2. So it's a 2-methylphenol because remove this CH3. The compound left is called phenol. Just benzene ring with 1 OH is called phenol. Then telling you 2 methyls is a carbon number 2. Then if this is 1, then this is 2. It is the same thing as saying 1 hydroxyl, 2 methyl. Then 1 and 2 still remains ortho, and hence the name is O-chrysol. And here it becomes your metachrysol, then parachrysol. Okay? Thanks for watching. You have to stay subscribed to see more on how to name disubstituted and tri-substituted compounds of benzene. Sa Majesty's World Science Channel is the best. That's the home of science, indeed.
Our parent chain is Earth because it contains 2 carbon, and the functional group there is COH. Then we have ethanoic acid first. So at carbon number 2, you notice there is OH there, and the same carbon number 2 there is phenyl group, which gives us 2,2-diphenyl and then 2-hydroxy. In alphabetical order, there should be hydroxy before phenyl. Therefore, the name is 2-hydroxyl 2,2-diphenyl ethanoic acid, commonly called benzylic acid.